We've had a 3.7 magnitude earthquake today in South Dakota. It rattled the whole state of South Dakota and parts of North Dakota to the north and Nebraska to the south. And you can see it's in the central plains of the United States, just under, of course, the Canadian border. We know that that's an area of magma. That's the stretching of the continental plate there. At one point around 990 million years ago, Yellowstone was smack dab right next to Lake Superior, the 2 o'clock lake that we see there, the big one. So you can see how much stretching has gone on, and of course there is magma under there. A lot of people don't talk about the fact that there is magma under there, but there is. The magma is basically a horseshoe-shaped thing that's been there since 990, about a billion years ago. Horseshoe-shaped over the Great Lakes. The western part comes through the central Great Plains towards Texas, and the eastern part goes towards the New Madrid seismic zone, which is basically a rift valley. Let's take a look at the maps. Here we are at Sizewell Berkeley. This is it, 3.7. Okay, and it's about 6 miles down. And here we are, South Dakota. 427 people reported it, so it must have been thousands that felt it, of course. As we said, it's all across the state of South Dakota. Let's pan in again. You can see that USGS stops the shake frequency at this square. It doesn't mean that it didn't go out to this area. This is very intense shaking. Let's go to the topographic. Okay, this is North Dakota, and this is Nebraska. Okay, and this is, of course, Yellowstone right here. This shaking could have been going up to here. I don't even know if Yellowstone supervolcano had been shaken from that, but it's not good having such strong quakes next to a supervolcano, as we know. Let's go back to what they believe could have caused this. The tectonic summary: natural occurring earthquake activity. Most of North America east of the Rocky Mountains has infrequent earthquakes, and here and there earthquakes are more numerous. For example, in the New Madrid seismic zone centered on southeastern Missouri, the Charlevoix-Kamourska seismic zone of eastern Quebec, New England, New York, Philadelphia, Wilmington urban corridor, and elsewhere. However, most of the enormous region from the Rockies to the Atlantic can go years without an earthquake large enough to be felt, and several U.S. states have never reported damaging earthquakes. Earthquakes east of the Rocky Mountains, although less frequent than in the West, are typically felt over a much broader region than earthquakes of similar magnitude in the West. East of the Rockies, an earthquake can be felt over an area more than 10 times larger than a similar magnitude earthquake on the West Coast. It would not be unusual for a magnitude 4 earthquake in eastern, central, or central North America to be felt by a significant percentage of population in many communities more than 60 miles from its source. A magnitude 5.5 earthquake in eastern and central North America might be felt by much of the population out to more than 300 miles from its source. Earthquakes east of the Rockies that are centered in population areas and large enough to cause damage are similarly likely to cause damage out to greater distances than earthquakes of the same magnitude centered in western North America. Now, most earthquakes in North America east of the Rockies occur as faulting within bedrock, usually miles deep. Few earthquakes east of the Rockies, however, have been identified, definitely linked to mapping geological faults, in contrast to the situation at plate boundaries such as California, San Andreas, where scientists can commonly use geologic evidence to identify the fault that has produced a large quake. But we know from, going back to this, we know from Geology 101 that every river is a fault line. Let's go back, let's pan in. This is the epicenter is the yellow stars we can see. Okay, where are we? There it is. Okay, there's right on the banks of a river. Okay, right on the banks of a river. There you go. I don't know what river that is, but anyway, that's a wide enough river as well. There you go. And panning out. Is that what becomes the Mississippi? Where is it? It goes all the way down. Let's go down. No, I can't see it. I pulled out too much, but anyway. Pulled out too much, sorry. There it is. Wide enough river. Okay, and then it goes this way, meanders all the way down. There it goes down that way. There it is, there it is. It gets lost somewhere there. Anyway. So, where are we here? Okay, so it is on the banks of a river, and as we learned in Geology 101, which I took in Queens College, it was a beautiful course. We even went to a zinc mine in New Jersey, all the way down with our hard hats, took the elevators down with the mine workers. Amazing. And first thing you learn is every river is a fault line. So we do have a lot of rivers, and that one is a big one. Please leave your comments. Thank you for your support. All of you be alert whether you're on the East Coast or the West Coast. There we go. That's it. See, East Coast has been having earthquakes as well. 1.3. Even Montreal, Quebec, 2.3, 1.3. New York. And let's remember that there's 30 underwater volcanoes right there. There they are, pointing towards Maine and Massachusetts. Okay, so all of you there, please be careful, west and east. And let's hope that there's no, that's not a foreshock, or, maybe it's the main shock. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.